Hey guys, we got quite a treat for you today. We're looking at what I call multivariable equations, and we're solving for one specific variable within that equation, okay? And another name for this is just a formula. So a formula is just, another name for an equation that's got lots of variables in it. And we're going to see equations or formulas that consist of 3, 4, maybe 5 different variables. They're going to pick one specific variable that they want us to solve for or isolate within that equation. So it's going to be crazy just because we're working with so many variables and letters and stuff, and we're not going to see hardly any numbers, but that's okay. We're going to be all right, especially with a little bit of practice. So what are we going to see in this video? So they're going to throw a formula at us, maybe something like this bar right here, and they're going to pick a variable that they want us to isolate. In this case, it's P. So we're going to try to isolate the P, but they could change their mind and ask us to solve for Q or solve for F. It doesn't matter. Or here's another example of a formula here, and they may just want us to solve for S. So those are some examples we're going to get into. Now, what exactly, again, does this mean to solve a formula for one of its variables? Well, all we're really doing here is we're solving a formula for a variable means rewriting that formula so that the variable is isolated on one side of the equation. So in this previous example, if we're solving for P, we're going to use all of our algebra skills to manipulate this equation until P is on one side of the equation all by itself. Now, this does not mean that we're obtaining a numerical value for that variable. In other words, when we're all done today, we're not going to get x equals a numerical value or p equals a numerical value. It's not x equals 2 or p equals 5. Our final answer is going to be p equals blah, 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 like this big formula thing. Treat the variable that you're solving for as if it were the only variable in the equation, okay? Think of the other variables as if they're just numbers. You could pretend this Q was a 2 or this F was a 5, whatever the case might be, if that helps you. But this right here is probably more important than I can stress as we go forward here. Now, we're not going to tiptoe around this topic too much. We're going to dive right into by far, I think, the hardest one we're going to see today. Why not start with the hardest one, right? Okay. So this opening paragraph kind of describes where some of the variables came from and what this formula, describes in real life. And that's up to you. It's I'm going to kind of skip over that part. So again, our goal is to try to solve for P. Now, this first method that I want to talk to you about is using a common denominator to combine the two fractions on the left into one fraction. And this is probably what you're more accustomed to. So can I look at these two fractions right here, come up with a common denominator, and combine them into one fraction when it's all said and done? So I think the common denominator is going to be PQ. So I'm going to multiply the first fraction by Q over Q and multiply the second fraction by P over P. So what that's going to do for me here, let's see. So this first fraction is going to give me a product of Q over QP. And you could write PQ if you want. And the second fraction is going to give me P over QP. And then it's still equal to 1 over F. So I haven't done anything there. Now I'm going to combine these two fractions into one fraction. So it's going to be Q plus P all over Q times P. What this allows me to do, the whole reason I want to combine the left side into one fraction is it opens up this opportunity to cross multiply. So when I cross multiply right here, I've got to be real disciplined and distribute the F to both of these terms right here. So it's going to be F times Q plus F times P, and then cross multiply here to get QP. Now, remind yourself here, who are we solving for? We're trying to solve for P. And what makes this problem so unique and so challenging is that you've got more than one term that has a P in it, right? What you want to do is work really hard to get those two terms on the same side of the equation. Get everything that has a P in it on the same side. And I think our best opportunity here is to subtract this FP to the other side. Those cancel. We'd get F times Q equals... Now, these bars here are not like terms, so we're going to rewrite them separately. Now, here comes the most pivotal step, probably the step that you want to star in your notebook and highlight. We are going to factor a GCF out of that side right there. And our GCF happens to be none other than the variable p. So on the left side, we'll go fq still, and then we're going to factor out that GCF, leaving me with q minus f. And the last thing to do is to divide by the quantity q minus f. So these quantities cancel. We're left with p equals fq all over q minus f. And that looks messy, but that's our final answer. Remember, we said we weren't going to get a numerical answer today. We're not getting p equals 2 or p equals 8 or whatever. We got p equals, something crazy. Now, before we jump boat here, I would actually want to redo that same problem, but I want to show you another method that I personally prefer over the one that I just showed you, okay? And what I'm going to use is I'm going to try to identify the LCD for all three terms, not just the first two, but all three, okay? Now, the LCD for all three of them is going to be PQF, the product of PQ and F. I'm going to distribute that throughout the entire equation. Everything on the left, everything on the right. So I've got to distribute the PQF 3 times. And as I start to distribute, okay, on the first distribution, I'm going to get PQF over 1 times 1 over P. On the second distribution, I'll get PQF times 1 over Q. And on the third distribution, I'll get PQF times 1 over F. And you're thinking this is something like, wait a minute, method number 2 looks way scarier, way more work, blah, blah, blah. I'm telling you, basically what I just wrote out, I wrote it out for extra clarification. This is a step after a little bit of a practice that you'll be able to do right in your head every single time. And so what happens here? You're going to see when I multiply these two fractions, the p's cancel, right? And I'm left with QF. And then right in this here, you're going to see the q's cancel, and you're left with PF. And then for this one here, we're going to cancel the F's, and you're left with PQ. Now, I tell you what, I don't know what that looks like on your screen, but that green is not showing up well on mine at all. So, okay, I'm going to go back to black ink here. At this point, I'm at the exact same point I was on the last problem. I want to try to get all the P's on one side. So I'm left with QF equals PQ minus PF. I'm going to do a GCF. So I got QF equals GCF of P, quantity Q minus F. And then just divide that quantity Q minus F to the other side. And we get the exact same answer we had on the last one. So that's the hardest part today. We're really, I think you're going to enjoy the next couple. They're much easier. And we're going to try to solve for S right here. And we're in a situation where we can cross multiply right now. So if we pretended B was over 1, cross multiply, just again, be very disciplined. Make sure we distribute the B to both of these terms right here. So we're going to get BS minus BV equals F times 1. We're going to add that BV over, leaving us with BS equals F plus BV. You could have wrote BV plus F if you wanted to. And then just divide by B. So when we're all done, we're getting S equals F, or P, okay. F plus BV all divided by B, and that is my final answer. Hey, I got one more cooking here for you. Now, the surface area of a rectangular prism, such as maybe a shoebox, is represented by A equals 2LW plus 2LH plus 2WH. We're going to solve for H. So we've got to try to isolate the H. Now, you'll notice, here's the trigger. There are more than one H in this formula. There's more than one term that contains an H. So I want to isolate these two terms on the right-hand side together. So to isolate those terms, the first thing I'm going to do is subtract 2LW from both sides. So I'm going to get A minus 2LW equals 2LH plus 2WH. And again, here's the move that you want to probably star and highlight in your notebook. We're going to factor out the GCF. Okay, GCF. And our GCF just happens to be none other than the variable H. So I'm going to go A minus 2LW. And boy, that's going to look like a 21, isn't it? I think I got to go cursive on my L's so that it doesn't look like a 21. Do a GCF of H. I'm left with 2L plus 2W. And then just divide that crazy quantity 2L plus 2W to the other side. And even though it's getting a little crazy and obnoxious on the left-hand side, we're totally okay with that. And for my final answer, I'll say H equals A minus 2LW all over 2L minus 2W. And that's my final answer. So I think we had a pretty good pace there. Hopefully it wasn't too fast and you're ready to dive into some practice examples. All right, good luck, guys.